Good evening. My name is Abdul Bari. I welcome you all on behalf of ACE Engineering Academy to the preparation strategy session for the subject of engineering mechanics. This subject of engineering mechanics is a common subject for three branches: mechanical, civil, and production. For all the three branches, the subject is a very fundamental subject. There are many more subjects which are depending on mechanics. Okay? Let us start first of all with what we are going to discuss in this particular session. We will first of all start with syllabus. We will start with understanding what is the syllabus of mechanics in all three branches, in every examination, in GATE examination as well as ESC examination. After having understood the syllabus, we'll move further to discuss regarding what is the weightage of this subject in various examinations. Weightage of this subject in various examinations. After having discussed this, we'll talk about the sequence of importance. Sequence of importance, which means which topic is more important, which topic is relatively less important. What should you give more concentration towards? That we will discuss over here in sequence of importance. At the end, we'll try to close this session by talking about some standard reference books. We'll talk about some reference books. Okay. Let us start now. We'll start first of all with the syllabus. You see, mechanics is a very fundamental subject. Every subject you study later on in your engineering will eventually somehow depend on mechanics. Fine. Now, this mechanics subject is having two branches. One branch is known as statics, the other branch is known as dynamics. Statics is a part of mechanics in which you are dealing with bodies which are not moving, which are at rest basically. Okay? Right. So over here, we are having two parts in mechanics, let us say. We are starting with, first of all, statics. We'll talk about statics. We'll talk about statics. There are 5 chapters under statics we are having. The first chapter we are having is the most fundamental chapter. Any subject you start studying, the first chapter, the most fundamental chapter, will talk about the various parameters your subject is dealing with. For example, you study the concept of strength of materials, you will come across stress and strain. You study fluid mechanics, you will talk about various properties of fluids. Likewise, in this chapter also you are going to talk about, in this topic you are going to talk about the parameters our subject is depending on. There are 2 parameters, namely force and moment. Your subject will more or less deal with these 2 parameters. So first chapter's name is System of Forces and Moments. System of Forces and Moments. Very fundamental chapter. You can say every other chapter to come later on is somehow related with this chapter of System of Forces and Moments. After having spoken about this chapter of System of Forces and Moments, we'll move towards the next chapter, which I personally regard as the most important chapter in entire statics. The reason is, everything else to follow in statics is somehow based on the second chapter only. This chapter is known as equilibrium. It is known as equilibrium. This is a chapter of equilibrium, right? In equilibrium, we are going to talk about what are the conditions required for a body to have zero acceleration. So you'll discuss over here, summation of force should be 0, summation of moment should be 0. All these things we'll discuss over here. But more importantly, when we speak about equilibrium, we are going to talk about something known as free body diagram. This topic of free body diagram is what makes this chapter very important. Right. In your dynamics also, you'll have to draw free body diagram. Likewise, in the next chapters to come, you'll have to somehow draw free body diagrams. And I'll tell you, this is a topic in which people have a lot of difficulty. Free body diagram, even though people have drawn many free body diagrams, in numerous free body diagrams, still they always have some difficulty in this topic. What I'm going to do is tomorrow's class, where we are going to discuss some important concepts in mechanics, I'll discuss how exactly to draw free body diagram and what is the difficulty people face. All those things we'll discuss tomorrow in the concept of free body diagram. Moving further, The third chapter over here, which is eventually based on equilibrium. So let me write 3 over here, eventually based on equilibrium. This is the chapter called as friction, very famous chapter and a slightly lengthy chapter, friction. And this has become more important for mechanical people in the recent past, since IIT Bombay, when they have reviewed the GATE syllabus, they have included multiple topics in friction. Previously, we were not having the concept of wedge friction, we were not having the concept of screw jack, but recently IIT Mumbai, when they have reviewed the syllabus, they have included those topics as well, right? So friction is quite a lengthy chapter, very important chapter. Generally, mechanical paper and civil paper have one question coming in common from friction, okay? This topic of friction is having 2 parts. Again, one part of friction will deal with the concept of equilibrium, where the body is still in equilibrium. One part of friction will deal later on in dynamics, where the body is having some acceleration and still friction is there. That friction more commonly is known as kinetic friction or dynamic friction. Over here, mostly we'll talk about something called as static friction. Moving further, the 4th chapter over here is specifically only for mechanical people. Specifically for mechanical people. This chapter is known as analysis of trusses and frames. Analysis of trusses and frames. Trusses and frames. You can say this is directly linked with this chapter of analysis of trusses and frames is an offshoot of equilibrium. Okay. I can give you a question based on truss without even letting you know it is a truss. You must be still able to answer the question only because you know the concept of equilibrium. So basically it is an offshoot or a branch, direct branch or direct offshoot of equilibrium. Over here we'll talk about what is the difference between a truss and a frame, how to analyze trusses. There are 2 methods, method of joints, method of sections. Likewise, how to analyze frames. All those things will be discussed in this topic. This topic is not present in our syllabus for civil engineering. As a matter of fact, this is a very important topic for them. But they study this topic under structure analysis. In SA, they are going to study this particular topic. So from engineering mechanics point of view, they are not going to study this thing. So this is specifically for, you can say, mechanical engineering and production engineering. This is specifically for mechanical engineering and production engineering. Lastly, there is a chapter, 5th chapter, which is dealing with the concept of something known as virtual work. Virtual work. Sometimes what happens is, analyzing equilibrium by standard equations of equilibrium becomes very difficult. For example, you are having multiple connected bodies. Machines are there. So in those cases, mechanisms are there. In those cases, analyzing the equilibrium by fundamental equations like sigma f vector 0, sigma m vector 0 becomes extremely difficult. So in those cases, we assign something called as virtual displacement, which is creating a virtual work. From there, we are going to get whatever unknown is present. So this also is a topic of equilibrium, but it is a non-conventional way of identifying the equilibrium conditions. This entire thing over here is regarding the concept of statics. Over here, the body is more commonly, you can say, at rest. Fine. Whereas in equilibrium, a body can be moving, but what is required is acceleration should be 0. Anyway, this is a syllabus which is common for both mechanical, civil, and of course production also, except this topic, which is only to be studied by mechanical and production from here. Civil people will study this topic from the structural analysis topic. Moving further, the second part of our subject is dynamics. The second part of the subject is dynamics. Second part of the subject is dynamics. Dynamics is not present for civil people at all. Dynamics is only for mechanical people. You can see dynamics topic is only for mechanical people. This is only mechanical. In production, questions don't come on dynamics, even though it is a part of production also. Questions don't generally come from here. Now in dynamics, we are going to have two parts. Dynamics can be broadly classified into two parts. It can be classified into two parts. What are these two parts? The first part of dynamics is known as kinematics. The first part is known as kinematics. The second part of dynamics is known as kinetics. Second part is known as kinetics. In kinematics, you are going to study the motion of a body while neglecting the inertia of a body. So over here, if you see any kinematic parameter will have its parameters dimensions in the form of m power 0, l power something, t power something. The reason is over here you are neglecting the inertia of the body. Basic mass of the body is not considered. For example, if I say I'm throwing a ball towards you, what is the range it is going to take to reach towards you? When I ask you what is the range it is going to take, you will ask me what is the velocity of the ball I'm throwing and what is the angle at which I'm throwing, what is the field of gravity I'm having over here. That much is sufficient. You will not ask me what is the mass of the ball. If you want to find out the range of the trajectory, you will not ask me regarding the mass of the ball. That means inertia of a body is not important to study over here. That part of dynamics is known as kinematics. Since inertia is not important, even FBD is not important. Free body diagram is not important. You will see over here, you will not have any regard for free body diagram, right? In kinematics, there are two parts again. There are two parts in kinematics. Two parts in kinematics. The first part of kinematics is going to deal with particles. The first part is going to deal with particles. Particle basically is something whose dimension is not significant with respect to the frame of reference. Okay. For example, this marker in my hand is not a particle. But if this marker in this 5-story building is as good as a particle because its dimensions are negligible with respect to this entire building. So particle is something which is not absolutely defined. It is relatively defined. It is relative to the reference you are dealing with, right? So we'll have kinematics of particles. Apart from kinematics of particles, you are going to have something called as kinematics of rigid bodies. Kinematics of rigid bodies. Rigid body kinematics. Now coming to kinematics of particles. In kinematics of particles, you are again having two parts. There are two studies in kinematics of particles. The first study in kinematics of particles is known as rectilinear motion. By rectilinear motion, we mean motion is taking place, the particle's motion is taking place along a straight path. So it has only one degree of freedom, the two translational degree of freedom. That kind of motion is called as rectilinear motion. The second type of motion over here is, let us say it is having 2 degree of freedom, 2 translational degree of freedom or 3 translational degree of freedom. This can become something called as curvilinear motion. So in curvilinear motion, the particle is going to move along a curved trajectory. So you have rectilinear and curvilinear. One interesting thing to note over here is when I'm discussing regarding particle, I am not talking about rotational degree of freedom. Because when it comes to particle, we don't define its rotation at all. Okay, particle for us does not rotate. It has no effect of rotation about its own axis. Of course, about some other axis it can rotate. But that rotation about other axis is equivalent to curvilinear motion only. Right? Moving further, coming to rigid body. Now when it comes to rigid body, a rigid body can have both translational effect as well as rotational about its own axis effect. Over here there are two motions we have. The first motion is known as fixed axis rotation. So imagine I'm taking this calculator over here, I'm drilling a hole over here, and about this particular axis, the only thing the calculator is allowed to do is it is rotating because I have fixed the axis. So this kind of motion is fixed axis rotation, where a body has only one rotational degree of freedom. Now, second motion over here is the most important of all the motions for you, which is known as general plane motion. General plane motion. What happens in general plane motion? Imagine I am having this calculator, which is a body for me. I am having this body or calculator in this particular plane. The plane you can see, the screen you can see, it is present. It can translate in this plane. It can also rotate in this plane. But it is arrested in the plane. It can only move in a particular plane. That kind of motion is known as general plane motion. Now this is a very important part for mechanical people. As such, for civil people, dynamics is not important. It is only important for mechanical people. In all these things, for mechanical people, the most important topic shall be general plane motion only. The reason again, because you see that later on when you study theory of machines, you will come across the concept of mechanisms over there. When it comes to mechanisms, you will find out that mechanisms elements are basically having general plane motion only. For example, you take the concept of a connecting rod in a 4-bar linkage mechanism. It is going to observe general plane motion. There also you come across eye center. Over here also you will come across something called as instantaneous center of rotation. So here comes the concept of eye center method or instantaneous center method. So this is regarding the concept of kinematics. Now coming to kinetics, over here, what do we have? Over here we are having 3 topics. The first topic over here is solving the problem by Newton's second law. So kinetics by Newton's second law. Newton's second law. What do you mean by Newton's second law? It's very famous law. You must be knowing summation of force vector is equal to mass times acceleration vector. Newton's second law. Likewise, in rotation, you can say net torque is equal to I alpha. This is Newton's second law. So in kinetics, you are having inertia of a body into picture. Therefore, free body diagram, you will have to welcome free body diagram again. Free body diagram will come into picture again. So the first method of solving problems in kinetics is by Newton's second law. Sometimes what happens is analyzing by Newton's second law becomes difficult. So from Newton's second law only we are having some substitute methods. The first substitute method we are having over here is known as work energy theorem. Work energy theorem. Mind you, this work energy theorem also is an effect of Newton's second law only. And it is relatively easy to work with. What makes it easy is the fact that over here you're dealing with scalar quantities instead of vector quantities. When you talk about Newton's second law, you see over here I have mentioned the vector nature of both force and acceleration. So you're dealing over here with the concept of vectors. Whereas coming to work energy theorem, you don't have the concept of vectors. Work and energy, both of them are scalar quantities. This makes this analysis relatively simple. The third method over here, sometimes even work energy theorem is not very helpful for you. So you'll have to go over here for something called as impulse momentum theorem. Impulse momentum theorem. Impulse momentum theorem. So third method we are having, alternate method in place of Newton's second law, is to deal with the concept of impulse momentum theorem. Over here we'll come across a concept of law of conservation of momentum. You'll also have angular momentum. We'll talk about what is law of conservation of angular momentum. We'll talk about coefficient of restitution. All these things will be discussed over here. Apart from this, there is one additional topic. Again, this topic is specifically for mechanical people. This topic is coming from advanced mechanics. It is called as Lagrangian method. Lagrangian method. Again, this method is a scalar method, but the only thing is slightly more complex. Okay, this method is useful when a system is having multiple degrees of freedom and you want to develop the equation of motion over there. That time going by Newton's second law, drawing free body diagram can be rather difficult. So we go for something called as Lagrangian method. This would look very lengthy, but for some complex problems, this is rather easy compared to Newton's second law. Fine. This is a syllabus in dynamics. Now, in dynamics only, there is one part. There is one part which is present only for civil people. So what I'm writing over here is only for civil engineering. This particular topic is only civil engineering topic. This topic is only civil engineering topic. As a matter of fact, the topic I'm going to write over here is also part of mechanical syllabus, but they study that in theory of machine and vibration. Okay, so we are going to take this topic from mechanics point of view only for civil people. The name of this topic is free vibrations or natural vibrations. Free vibrations or natural vibrations in single degree of freedom. Single degree of freedom. Achha, one more thing, this is without damping, undamped. We are talking over here about undamped vibrations. Free undamped vibrations in single degree of freedom. This happens to be the most easy part of vibrations. If you talk about the difficulties which can be created over here, how can this problem be compounded? You see, the opposite of free vibration is forced vibration, difficult to analyze. Opposite of undamped vibration is damped vibration, where viscous friction can come into picture. Again, difficult to analyze. Again, you see over here how simple it is. You are having a single degree of freedom. Now, if you go for higher degrees of freedom, the concept will become rather difficult. So this is a very easy concept in vibrations, which is present in civil syllabus. Again, this is a recently added topic. 2 years back only, when IIT Mumbai conducted the examination, they have included this topic. Now this topic, let me also tell you, this topic has to be studied from the perspective of structural analysis. Structural analysis. It has to be studied from the perspective of structural analysis, and it is helpful for you when you are designing, in earthquake resistance and all those things. That time this topic will be helpful for you. Fine. So this is a syllabus we are having. So we have seen two topics, broadly you can say. One is statics, the other is dynamics. Statics was rather simple. Dynamics was more extensive, but it is only for mechanical that these topics are there. For civil, in entire dynamics, only one topic is there. My suggestion to civil people is, since you are studying free vibrations in single degree of freedom, I would recommend to you that please go through at least the concept of rectilinear and curvilinear motion. Without these things, it will become rather difficult for you to understand vibrations. Okay? Even though they are not directly a part of your curriculum, but please go through these two topics at least, and basics of Newton's second law to understand the concept of free vibrations. Because one way of analyzing vibration is to go for Newton's second law approach. Sometimes we also go for work energy approach. So these things, they are not directly present, but having a superficial idea at least will be helpful in this topic. So this completes the syllabus of engineering mechanics in GATE examination perspective. Now coming to IS examination, this subject is not present for civil IS examination. It is only present for mechanical IS people, right? Now in mechanical IS also, dynamics is very rarely touched. Dynamics is very rarely touched. Mostly they are asking questions based on statics, and that too in statics they like to move around friction only. Friction is one of the favorite topics. Now moving further, let us talk about, after having discussed the syllabus, let us talk about the weightage. The weightage of this subject, let us start with first of all mechanical. Let us start with mechanical first of all. Coming to mechanical engineering, the weightage of this subject in GATE examination, previously it used to be very low. Recently it has drastically increased. So you can expect anywhere from 3 marks up till, we have also seen 8 marks coming in one paper. So the window has become rather wide. Okay, generally we talk about a tolerance of 1 or 2 marks, but over here I have given a tolerance of 5 marks over here. The reason is it has become unpredictable. There are papers where, one thing, instead of saying 3 marks, let me rather say 4 marks, because 3 marks is rarely coming nowadays. 4 marks at minimum you are having. Okay, recently in the recently conducted examination, we were having one paper where even 8 marks have appeared in mechanical paper. In IS examination, you can expect around, in prelim stage, you can expect around 4 questions to 6 questions in prelim stage. In conventionals, you can expect around 20 marks. You can say this is in prelims, this is in prelims. In conventionals, you can expect around 20 marks in IES. Now coming to civil engineering. Civil engineering. Since your syllabus is very, very less and relatively the weightage also is relatively less, over here you are having this subject only for GATE syllabus. You can expect over here anywhere around 2 marks to 3 marks. More 3 marks is extremely rare, very, very rare. Okay. Generally you get 2 marks to 3 marks over here. Fine, this is the weightage we are having. For production paper, generally you have one question coming. In entire production paper, we have only one question coming. And I have seen in the recent past, most of the times questions are coming from equilibrium or coming from trusses only. Okay, that is for production people. Now moving further, after having discussed the weightage, let us now talk about what topics are more important. Where do you have to give more, attention? Let us start first of all with civil people, civil engineering. Your syllabus is quite low, and likewise your attention also can be throughout the subject. But still, most importantly, the topic of prime importance for you should be equilibrium. Equilibrium should be the most important topic for you. After having studied equilibrium, go for the concept of friction. Friction. Generally, we see one question comes from friction. Generally. If it is coming from friction, you won't have a question from equilibrium. If you're having a question from equilibrium, probably you're not going to have from friction. So, either of these two topics will have one question. Third most important topic for you will be vibrations. Now, regarding vibrations, we can't be very specific regarding how much weightage will be coming from vibrations, because we have seen a question coming from vibrations only in 1 year. So we have a sample space of 2 years. In past 2 years, only in 1 year we have seen vibration questions coming. Before that, vibration was not a part of your syllabus at all. Okay? So you can say third most important topic over here is vibration. Fine. Questions, believe me, are extremely simple. Extremely simple questions are coming. Okay? Sometimes only one question is coming, and that time it is coming from friction. And all these questions, you will realize that all these questions are based only on one topic. More or less you can say it is only based on free body diagram. If you are very, very good with drawing free body diagram, automatically you will find your syllabus of mechanics extremely simple. Okay? This is for civil engineering. Moving towards mechanical engineering. When it comes to mechanical engineering, you are having a rather lengthy topic of mechanics. What should you give most preference towards? I would again suggest you, even though weightage wise it is less, but I would suggest to you that give more importance to equilibrium, because again over here you are going to learn the concept of free body diagram. Once you know free body diagram, automatically entire kinetics will become easy for you. After having seen equilibrium, next topic, most important topic, will be the concept of Newton's second law. Newton's second law. Next will be the concept of friction. Then general plane motion, and of course trusses and frames. Trusses and frames. Okay. This is where mostly the questions will come from. Sequence wise, you see, again, this is based on my experience. There is a possibility, a good possibility that something might appear above something else later in examination. But this is just an estimation we are having based on our experience. Fine. Again, I am giving most importance to fluid equilibrium over here. The reason being, free body diagram has its position placed on top always when it comes to mechanics. Fine. Apart from this, there are many more topics. For example, you are having Lagrangian. Lagrangian has appeared only once in GATE examination, And believe me, that was the most difficult question that year. Very difficult question. Okay. And that question, if you would see, it would take somewhere around 10 to 15, more than 10 minutes rather, 15 minutes at least, to solve the entire question. So sometimes you can have extremely difficult questions also coming. And recently also, there was a question from the concept of angular momentum, which has appeared in GATE examination. That was again a very difficult question. So sometimes questions coming from mechanical engineering mechanics are extremely difficult. Okay, they are taking more than 10 minutes to solve. But don't be demotivated. If a question is difficult for you, the good thing about that question is it is difficult for everyone in India, right? So that way you can take some heart. Moving further, coming to production engineering, I'm not writing over here. For production engineering, the most important topics shall be equilibrium and trusses. These two topics will be the most important topics for production. I would again suggest for production people, don't go into dynamics, even though it's a part of your curriculum, but you won't have questions coming from there, right? So this is regarding the importance of the various topics. After this, if we talk about the reference books, this is one subject which has many reference books. Okay, the reason why many reference books are present in this subject is this is a very fundamental subject. It is based on Newtonian mechanics mostly, Newtonian physics basically, right? You'll be having many reference books over here. My personal favorite is Vector Mechanics. Vector Mechanics, both statics and dynamics. Statics and Dynamics by Beer and Johnston. Beer and Johnston. As a matter of fact, they also have a book on strength of materials, and that book is going by the name Mechanics of Materials, I believe. Okay. Anyway, according to me, this is the best book basically for mechanics. Why have I written statics and dynamics? Because they are having two separate versions. Statics is a separate version, dynamics is a separate version, and then comes a book which is a combination of both these volumes, statics as well as dynamics. I would not suggest you to buy books, okay, because I do not know whether you're going to read or not, but mostly I have seen people, they buy books and they just keep in the shelves. So I would rather recommend, if you can find the PDF of this particular book to refer, better do that. Otherwise also, referring to books might not be such a good idea in the initial stage. Later on, once you are comfortable with the subject, then go for some reference books. Initially, try to develop the subject from the faculty itself. Apart from these books, there are some more books. For example, there's a book by Timoshenko and Young, again a very good book. Then you are having a book by Hibbeler. Hibbeler also is a good book. Merriam also is a good book. And one of my favorite books is F.L. Singer. I remember during my days of engineering, I have studied from this book, Singer and Peitel. Singer and Peitel. Okay, these are the names of authors. Actually, the book, of course, is going to be engineering mechanics only. Singer and Peitel was also a good book. I have studied from this book. Back then, Peitel was not there. I believe only Singer was there. The book's name was only Ferdinand L. Singer. It's also a good book. If you like to refer to Indian authors, the best book was by Ramamurtham, very famous author. Most of you must be knowing this author from Strength of Materials also, by Ramamurtham. But I'm not finding that print these days. So if you can find older books of Ramamurtham, it's good for you. Otherwise, you can also go for a book by the name Tayal. One book is there by the name Tayal, Mechanics by Tayal. That is also a good book. Okay? But the problem with what I have found with Indian author books is mostly they do not go deeper into the concept of dynamics. When it comes to statics, it's really good. Okay? In basic dynamics also, fine. But when it comes to difficult part of kinetics, that is where this book will it will rapidly go superficially. It does not go into depth when it comes to kinetics, right? Even though this book is also quite good, right? So these are some reference books for the subject. Now, one suggestion or some preparation strategies that we mention for this particular subject. If you want to be good at this subject of mechanics, there are three things you have to be good at. Three things you should be good at. First thing is geometry, plane geometry. You should be really good at plane geometry. Please understand, mathematics is a language of physics. So if you want to be good at anything of physics, you have to be good at corresponding thing of mathematics. Our subject depends heavily on visualization, heavily on geometry. So this is where, I have seen people who find mechanics difficult, and when I talk to them, somewhere I realize that their plane geometry understanding is not good enough. Especially when it comes to the concept of parallel lines, how to identify which angle and which angle are going to be equal, what is alternate interior angle, what is corresponding angle, all these things will become important. If you are finding any difficulty with this, let me tell you where you can find some help. You can find help in NCERT mathematics textbooks, starting from 6th class up till 10th class. And again, you don't have to, refer to everything over here. Just refer to the basic things which you are not aware of or which you have forgotten probably. So you can refer to these things. And NCERT books are very well available. By NCERT themselves, they are giving PDFs for free. You can refer to them. Apart from plane geometry, the next thing that is important is trigonometry. Trigonometry and basic trigonometry. You should know what each trigonometric ratio is physically signifying. You should know some basic trigonometric identities. What is sine square plus cos square? What is 1 plus tan square? Likewise 1 plus cosecant, 1 plus secant square, and so on. You should know how to talk about compound angles. What is sine of 2a? What is sine of a plus b? Likewise, basic trigonometric identities are very, very important. Apart from these two things, one more thing that is important is calculus. Calculus, everyone thinks they know calculus. Okay, if I give you a differential equation and ask you to integrate, probably you'll be able to do it. But if I give you a problem in Word and I ask you to create a differential equation, that is where people find difficulty. So calculus is not about just differentiating and integrating. Calculus is about feeling where it is important. How to create a differential equation, that is also part of calculus. So you should know some fundamentals of calculus. I'm not asking you vector calculus and all those things. Some basic calculus is required to study this particular subject. Any subject basically in engineering, some basic calculus is always required. So see to it, if you are finding this subject difficult, please refer to these things. Try to identify where you are having weakness in these three topics. Once you identify, mostly it is going to be this thing, even though it is very simple, but people have forgotten. This is very long back topics, right? NCERT book, I'm talking about 6th class or 10th class. It's been many years probably you have seen these books, right? So it happens. You might have forgotten. You might have, the things are not making sense to you very quickly right now when it comes to plane geometry. But once you refer, brush those topics, eventually become fast at that. Okay. So once you identify which topics you are difficult in and you're able to overcome those difficulties, automatically you'll be good at mechanics as well. So this is regarding the preparation strategy for mechanics. And one more thing, regarding the test series, I would recommend you to take the test series immediately after completing the subject. It will help you identify how much you have understood, what more depth you have to identify. And ACE Academy is taking very good care of designing some really good questions for your test series. Sometimes the questions might seem difficult to you, but don't be disheartened, because we have to cover every type of question. Okay, we have to cover every difficulty level of question that can be expected in examination. And examination, let me tell you, is becoming more and more unpredictable as days are passing. Okay. So sometimes, the result in test series might not be up to what you are expecting. So don't be disheartened. But I would suggest you to please give a lot of importance to test series. Test series will help you know where you are lagging, what you have to do further to empower yourself in GATE examination. One more thing is, please write some short notes. Write short notes. Whenever you are referring to any subject, you are probably writing some notes, or you're not even writing some notes probably. Either way, what is happening is you are not going to refer very easily to the notes. If you're writing everything in detail, you will feel lazy to refer to everything later on. So my recommendation to you is at least make some short notes which are of prime importance, so that less time you can cover more topics. Okay? And lastly, I would suggest you to please practice previous gate questions and previous IAS questions. One thing that will help you understand what kind of questions will come is what has already appeared, right? What has already appeared is a good example of what is probably going to come later on. So previous gate questions and previous IAS questions are also good practice. This is hopefully helpful for you. And tomorrow I'll take a topic of Newton's third law and free body diagram to help you understand some fundamentals of mechanics. Thank you.